welcome back to my YouTube channel. I hope you've been fine. So in our previous video we were discussing about preliminary works before commencing the actual project that you may be given. So this is the continuation. We had handled various factors that should be put in place when you want to allocate plant in your site, or within your site. So today we are going to difficulties encountered when working in a bad weather. Difficulties encountered when working in a bad weather. Remember, when you are doing preliminary works, you must first get to know the place where your project is going to be done, and you may know the various weather conditions that are mostly experienced in those areas, and you must also prepare yourself on how you can curb them so that your work may be done in a proper way and you may do a quality work. So there are various difficulties that you may encounter as a constructor or a contractor or a skilled laborer or an engineer who is doing that specific work. There may be rains in those areas where your project is done. There may be high winds, there are low temperatures, there are poor daylight levels, and any other thing that may affect your work. So you must get ready properly on how you'll curb them. So like for the first one, how to curb difficulties of hot weather. When you're working in a place where the weather is too hot, how will you curb that kind of weather condition? So the first point is, in a very hot weather, the freshly laid concrete should be shielded from the direct sunlight until 7 days to prevent rapid evaporation due to temperature, relative humidity, and wind. Remember, concrete settles due to hot sunlight. So when you're working in those places where it is very hot, like the northern part of Kenya, for example, you must cover your concrete. The concrete that you've laid, you must cover it so that the moisture may not evaporate due to high humidity and wind. Then the mixing water that you are using and the material must be kept as cool as possible. Your water will be kept cool so that when you are using it to mix, its temperature is so much lower that it may not evaporate easily. Then the aggregates should also be protected from sand and sprayed with water to cool down immediately. The aggregates that you are using, you must ensure that you are using aggregates which are wet, so that when there is the hot weather, it will take time for it to evaporate the water that has been used to wet the aggregates. So when you are covering the concrete surface, you may use various things like the bags of cement. You may use. There are other various materials like anything, just anything that you may use to cover it so that the water inside the concrete may not evaporate. So there is also, before I forget, remember, hot weather will lead to quick settling of concrete, and hence that concrete will be weak. Concrete should have a minimum settling time, and if it settles faster than the required time, it will be weak and the strength of that concrete will not have been attained. So you must cover it to allow it to settle in its own pace, not to be fastened by the hot weather. So we have how to curb difficulties in cold weather. When you are working in a very cold weather, remember, cold weather will delay the settling of concrete. So you must put various precautions or measures that you'll use so that your concrete may not settle slowly. The first thing that you'll do, all aggregates should be preheated by perforated steam pipes to prevent the attack of frost. So you heat the aggregates that you are using so that they may not, before they get to the temperature, the lower temperature of that place, it will have settled. Then the next thing is mixing water must be heated. The water that you are using to mix the concrete, you will also heat it so that its temperature may be high, and that will allow your concrete to settle at the required time. Then there is also concrete must be cured for a long period due to fact that the low temperature retard concrete hardening and strength again. So curing that is done to already laid concrete will be done for a longer time so that the concrete may harden properly and the strength may be achieved. You also have the additional Portland cement. High curing temperatures, a high early strength cement and other known methods may be employed to obtain high early strength. You may use a specific type of cement that will not settle, um, that will not be affected by the cold weather. So you may be preferred so that you may not use the normal cement that we use, so you use a specific one that the temperature is higher, which will allow your concrete to settle at the right time. Then the next thing that we had is the site and soil investigation. Before you construct or you erect any structure in a given period, you must first do a soil investigation and know that you do a soil investigation and know the kind of soil that you are going to work on. Soil investigation also will help to know the bearing capacity of that ground. Yeah, so it is a very key point when doing a preliminary work. So there are various methods of classification, soil classification. We have physical properties. You classify soil due to its physical property. Then you have the geological origin. Then you have the chemical composition. That is the chemical content available in that soil. Then you have the particle size distribution. Those are the various classification. Then generally soil are defined as coarse-grained or fine-grained, each resulting in different properties. So we have the coarse-grained. These include like sand, gravel, having a low proportion of voids, negligible cohesion when dry, high permeability, and slight compressibility, which takes place almost immediately upon the upon the application of a load. Then you also have fine-grained soil. Fine-grained has fine particles, and coarse-grained has a medium-sized particles. That is the major difference. So there are other things. There are, like we have for clay, which is a fine-grained soil. It has it is less than 0.002 millimeter of its size. Then the silt also is that way. Then the sand that way. Okay. Then we have why do we do soil investigation? Why do we do soil investigation? The first point why we do soil investigation is to determine the suitability of the site for the project that is proposed. When projects have been proposed, you do a soil investigation to ascertain that the kind of project that you, or the kind of structure that you want to erect in that particular place it will be safe, or it will not be affected by the ground of that particular place. Then you have to determine an adequate and economic foundation design. Soil investigation will help you to know the kind of soil that you are going to work on, and remember the kind of soil is what will lead you to the type of foundation that you'll use. Without doing soil investigation, you may exercise a type of foundation, or you may use a type of foundation that will not be cost effective. Then the other thing is determine the difficulties which will arise during construction process and the period. Then we have to determine the occurrence and cause of all changes of subsoil conditions. Then we have factors affecting method or choice of soil investigation. The first factor that affect the method and choice of soil investigation is the size of the contract, then the type of proposed foundation, then the type of sample required. Then the type of subsoil to be encountered. There are other main methods of soil investigation. There are various methods of soil investigation. We are doing soil investigation. You may use a trial pit, you may use boreholes. So they are explained. Trial pit primarily to obtain subsoil sample for identification, ascertaining the subsoil characteristics and properties. So this is how the trial pit is done. You just dig a pit and you take samples. The samples will do a test to the samples, of which you'll then know the kind of soil that you have. Then you have there are trial holes are used purposely to know the thickness of each layer of the subsoil, then to know the composition of each stratum, then to know the size of various particles of the subsoil, which is supposed in each stratum, then the condition of each stratum, then the water table will also be known when you are doing a trial hole or a trial pit. It is just generally a trial pit is just ideally it is just a hole that is dug so that you may know the layers of the soil of the place where you'll do your works. Then there are advantages. Then you do the borehole. Purpose of the auger hole. Okay, so this is how the borehole is done. This is the hand augers, the clay augers is there. Then the advantages of doing a borehole is generally it is cheap and it is simpler than a trial hole. Then we also had this setting out. Setting out, it is also part of preliminary works before commencing a project. So setting out is what is done, then you begin your project. So setting out is generally to transfer the the diagrams that are on the plan to the ground so that excavation works may be done. We just transfer the diagrams which are drawn on a plan to the ground. That is what setting out is. And then remember, setting out is done with a person who understands it best. When setting out is done with a person who does not know the kind of work he is doing, he will have messed the entire work. So you must be very keen. There are various equipment that are used for setting out, like a steel tape, which is used for measuring. We have a builder square, is used for setting out works to check the corners of the building. Then we have the crosscut saw and the nails. We have the pegs that are used for markings. We have the plumb bob and the spirit level, which are used to check the verticality and how horizontal the level of that place is. We have the side square, is also used for setting out of corners. Then we have the lines. Then while setting out is done, that is when you do datum establishment, which was the last thing to be done in preliminary works. So datum establishment is done. So it is generally a temporary benchmark which is established on site, so that each and every level will be done with respect to the temporary benchmark that is placed on that site that you are to work on. So this is how it is done. So if I may just do the definition, the datum or the temporary benchmark, the TBM is the temporary benchmark, is a basic level established on the site from which all measurements or levels of the building to be erected on the site can be taken. Yeah, I think that is what I've just said. Everything, all measurements and all the levels to be taken for the buildings to be erected should be taken from the datum level or the temporary benchmark. So it is done this way. Hardwood peg, and this is just something like a guard that helps anything not to tamper with the datum or the temporary benchmark. But this is the temporary benchmark. Yeah, if you can see my cursor, this is the benchmark. Okay, so It is done that way. Then there are requirements for setting out. Requirements for setting out. The first requirement while doing setting out, it should be in the correct position. Setting out should be done in a correct position, then be at the correct level, then be erected vertically. So those are the three requirements for setting out. Should be in a correct position, in a correct level, and erected vertically. So this is just to check. After doing setting out works, you must check the diagonals of what you've setted out, and you have a building line. Building line is a line where all measurements should not go beyond. All measurements are done as per the building line. You should not pass the building line. So we have the sequence of operation. This is just what will tell you how to do the setting out works. You first drive pegs on the sides of the boundaries. Yeah, it is just a clear description of how it is done. Then we have setting out of curves, like for roads. You will set out for curves. It is done that way. The profiles to hold lines, then tangential points, then we have the trammel, the peg, then the striking point. As you can see, that is still for setting out of a curve. Then you have also setting out of a right angle. It has the procedure there. The method of doing it is there. When you use a builder square, those are the diagrams of how to set out a right angle and a curve. When you use a side square, you do it this way. This is when you use a side square. Then when you use acute angles, it is also here. So those are just how setting out is done. So that is the end of our preliminary works. So thank you so much for watching this video. Please don't forget to subscribe, like, and comment, and may God bless you.